Okay, question 1. 2 metal balls are the same size, but one weighs twice as much as the other. So just looking at them, you wouldn't be able to tell that they're different, but one is twice as heavy. They're dropped from the roof of a single-story building at the same instant of time. So they're released from rest, and they have 10, 15 feet to fall. And the question is asking about the amount of time it takes for the balls to reach the ground. Will one take longer than the other? Might they reach the ground at the same time? Question 2. Okay, the 2 metal balls that look identical, same size, same shape, but one is twice as heavy as the other. They're rolling off a table at the same speed. So they leave the edge of the table at the exact same time, moving at the same speed. The question is asking about the horizontal distance away from the table that the balls are going to land. So how far away this way are they going to land? Might they land the same distance away? Are they going to land at different distances away from the table? Okay, question 3. You're dropping an orange from a second-story window, so like 20 feet above the ground. You're dropping it, you're not throwing it, so you're just releasing it from rest, letting it fall. Which of these statements do you agree with? If you agree with more than one statement, then maybe just choose the one that you think is the most accurate. Question 4 is about a head-on collision between 2 vehicles. Tragic. One is a very large truck, one is a very small car. The question is asking about the forces that they might apply on each other during the collision, while they're touching, while they're running into each other. Okay, questions 5 and 6 both use this diagram. So you're gonna have to refer to this diagram to answer both of these questions. So what the diagram is supposed to be showing is like the surface of a game. You're playing a game on a table, and this diagram is a top-down view, like a bird's eye view. So this plane is like the plane of the table. We're looking at it from above. So we have this curved track. It's like a chute. It's like a curved little circular tube. This ball gets shot in, and then the ball comes shooting out. Okay, so question 5, you've got to notice there's this little stipulation saying that it's very slippery, so imagine there's no friction. Basically, this is saying like, yeah, in real life, there would be some friction, but for the purposes of this question, let's ignore any effects that friction might have on this situation. So the marble is traveling in this curved track, and question 5 is asking about the instant in time when the marble happens to be at this point labeled Q for Quinn. So read the 3 forces that are listed here and indicate which of these forces, if any, happen to be acting at the marble at that moment. Question 6, same setup as in question 5. Remember, we're looking at this from the top down. This is like a bird's eye view. So this plane is really horizontal. It's like a tabletop. But we're asking, when the marble is done traveling through the chute ends here, the marble is exiting, which path is it going to take? Okay, question 7. We've got another diagram showing a top-down view. So this is like a bird's eye view. We've got this dude, he's swinging a ball on a string, like this, just swinging it in a perfectly circular path. So the question is asking, when he's swinging it and the ball happens to be at this point P, say the string snaps. The string snaps, it lets go of the steel ball. What the question is asking is, which of these paths is the steel ball going to follow? Okay, questions 8 through 11 all concern the same scenario here. We've got a diagram. This is another top-down view, a bird's eye view. This is a puck, like a hockey puck, sliding on a very smooth ice rink. So we're saying that, yeah, in real life there would be like some friction, but for the purpose of this question, let's just ignore any effects that friction might have here. No friction. We're taking friction, just putting it to the side. So the puck is sliding along at a constant speed, and when it gets to this point B, we give it a quick push, just a quick tap, just a quick push, one of those. Question 8 is asking, which of these paths is the puck going to follow after being tapped? Question 9 is asking about the instant in time right after we give that force to it. So we give it the little force, and then boom, the next moment, what is the speed of the puck, specifically compared to what its speed was before we applied the force to it? Question 10 is asking for a more extended period of time after we've given that little tap to the puck. How might its speed be changing? And remember, in this situation, there's no friction. No friction. Question 11 is asking you to refer back to that path that you chose in question 8. So after we have given the puck its little tap and it's following this path, what, if any, forces act on the puck now? Question 12 is pretty straightforward. Pretty self-explanatory little diagram. We're shooting a cannon straight horizontally off a cliff. Which of these paths would you expect the cannonball to follow? Question 13. You have a softball. Pretend this is a softball, and you're throwing it straight up in the air. After the ball has left your hand, what forces, if any, act on the ball? Question 14. We have this side view diagram. So we have this airplane that's traveling in this direction, and a bowling ball somehow falls out of the bottom of the airplane. Don't try this at home. So we're watching this happen from the side. Thankfully, we're not underneath this airplane. Watching from the side, which of these paths would you expect the bowling ball to take as it falls to the ground? In questions 15 and 16, we're imagining a school bus that got broken down and a little car comes along to help push it to where it's going. Question 15 is asking, when this car starts to push the school bus, which of these vehicles, if any, is exerting a larger force on the other? In question 16, we still have the car pushing the bus along, but now they've reached a steady cruising speed, so we can assume that their speed isn't changing. So we're basically asking the same question again. Which of these vehicles, if any, exerts the larger force on the other? In question 17, we've got a book. I have Persepolis. It's a graphic novel, and if you haven't read it, I highly recommend it. So in this question, we're lifting the book with our hands at a constant speed. I don't know if my speed is perfectly constant, but imagine it is. While I'm lifting the book up at a constant speed, this question is asking about the upward force of my hand acting on the book. Okay, in question 18, we have a girl on a swing. Let's talk about this diagram real quick. So she's on a swing attached to a rope, and we can say that the rope is fixed at point O. That's where it's tied to the tree or whatever she's swinging on. In the diagram, the girl is at point A, but it says that the girl started at a higher point. So, she's swinging. So read through this list of 4 forces here, and notice that each one indicates a direction. A force always acts in some direction. So read through the forces, think about them, and then indicate which of them you think happens to be acting on the girl when she's at position A. In question 19, we're talking about the positions of 2 women who are running. Notice that for each woman, there are 8 positions indicated, and they've all been taken, imagine them as snapshots at equal time intervals. So 0.2 seconds, it really doesn't matter what the time interval is. Just know that they're equal intervals between each of these marked positions. So we know the women are moving. They're moving at some speed. This question is asking, do they ever, at any point in their little run, move at the same speed as one another? Question 20 is pretty similar to question 19. We're still looking at these little snapshots in time of these 2 women who are running. We can imagine there are equal time intervals between each of these snapshots. But question 20 is asking you to compare the accelerations of the women. So look at their motion, think about it, think about how much each one might be accelerating, and then compare them. Okay, questions 21 through 24 all concern a rocket that's out in space. We can imagine that this rocket is far enough away from any planets or stars or any other bodies to have a force of gravity that's acting on it. So this rocket is really just out there doing its thing. Now we're talking about space, so direction is kind of arbitrary, but looking at this diagram, we can say that the rocket is moving to the right from point A to point B. The rocket itself is facing upwards. It's facing like this, so it's moving along this path like this. And then we're saying that when the rocket reaches this point, point B, it fires on its thrusters, and its thrusters are always pointing down. So the rocket is firing in the downward direction until it reaches some point C. And question 21 is asking you, what path is the rocket going to take? What's it gonna look like when the rocket is moving with its thrusters firing? In question 22, you're thinking about that path that you chose in question 21, and then think about the speed of the rocket as it's following that path. How would you describe the speed of the rocket between point B and point C? Now in question 23, we're thinking about when the rocket reaches that point C. Whatever path it took to get to point C, it is now at point C and it turns off the thrusters. So no more thrusters firing. Now that the thrusters are turned off, how is the rocket moving now? Question 24 is asking, along whatever this path is that the rocket follows after point C, after its thrusters are turned off, what is the speed of the rocket? How would you describe the speed of the rocket as it takes this path that you specified before? In question 25, we're talking about a woman pushing a box horizontally across the floor. There she is. So the box is moving along at some constant speed that's been labeled V0. Doesn't really matter what the speed is, just know that it's constant. Question 25 is asking you to think about the force that the woman is exerting on the box and describe it. In question 26, we're thinking about the same woman pushing the same box as before. She's strong. All of a sudden, she's applying twice as much force on the box as before. Now that she's exerting this greater force that's twice the strength as before, describe the speed of the box. In question 27, we're throwing it back to question 25 when that woman is just pushing along on the box at her constant horizontal speed. But all of a sudden, she just stops applying force on the box. What happens to the box? In question 28, we've got these two yahoos playing around in some rolly chairs. I think this guy's got pens in his pocket. That's cute. We've got this guy A and B. We see that A weighs a little bit more than B. A takes his feet, puts them on the other guy's knees, and gives him a push. This question is asking, while he's still pushing off, while they're still touching each other, pushing off, which of them, if any, exerts the greater force on the other? Question 29 has got a pretty straightforward diagram, literally just a diary resting on a nightstand. So read these three forces that are listed and indicate which, if any, are acting on the diary as it sits there. Question 30 has a pretty killer diagram. That's my mom playing pickleball. No, but question 30 is saying there's this woman playing tennis. She has hit the ball is traveling into the other side of the court. So while the ball is still in the air, so it's after it has left her racket and before it touches the ground, which of these three forces are acting on the ball?